In this video, we are going to be looking at question 2 of November 2023 paper 1 national examination. 2.1, we are given an arithmetic series 7. Let me just write here on the side. So we're given 7. Okay, let's see if it's full. Yeah. So we have 7, we have 12, and we have 17. All right, and then we have three dots to show that the pattern continues like that. All right, and then the first question, they want us to determine the value of term 91. Okay, the value of term 91 for 3 marks. Let's do that. So obviously, since we can see that, okay, this is arithmetic, because from 7 to 12 I have to add a 5, and then from 12 to 17 I have to add a positive 5, right? So we can see that there's a constant first difference of 5. So we need to now determine the formula of the nth term, which is Tn equals to a plus d into bracket n minus 1, right? And then we're looking for T91. And then we know that a is the first term, so the first term is 7 in this case, plus the difference, which is the constant difference of 5. We said n is 91 because we're looking for term 91, and then we have that. Then term 91 is going to be equals to, let's quickly press this on a calculator. So we have 7 plus 5 into bracket 91 minus 1. So we have 457. It's your final answer. So you get 3 marks there. Right. And then let's get the next question. Calculate the sum of 91 terms. Okay. So the sum of 91 terms is going to be this. We're looking for Sn equals to n over 2 into brackets a plus l, where l is the last term, a is the first term, right? You can use this formula, or you can use the normal one, which is this. Sn equals to n over 2 into bracket 2a, and then you have plus d into bracket d into bracket n minus 1. So you can use that one. Your n is 91, so you're gonna put 91 there. Your a is 5. Is a 5 or 7? Let's see. Our a is 7, and then our difference will be 5, and then you can get an answer. But I prefer to use this one because I know the last term. So I'll say, okay, S91, which is the sum of 91 terms, is the same as 91 over 2 into bracket the first term of 7 and the last term, which is the 91st term or 91st term, which is 457. Then let's press this on a calculator and see what we see. So we have 1 over 2, we have 7 plus 457. So this gives us 21112, and that is the sum of the first 91 terms. All right, now let's check the third question. They say calculate the value of n for which Tn equals to 517. Okay. Remember we said Tn is equals to a, which was 7, plus 5 into bracket n minus 1, right? That is our Tn formula. But here they are telling us that Tn equals to 517. So I'm going to replace the Tn with 517 equals to 7 plus 5n minus 5. Right, we're filling the 5 in there. And then now we're going to have this minus in there. So you have 517 minus 7, that gives you 510. So we have 510, which we're going to add a 5, equals to 5n, right? Sharp. So 510 plus 5. Remember, this 5 will come there to add. Ne? So we're going to add a 5 there. Sharp. So we have 515 now equals to 5n. So we need to divide 515 by 5 and see what we get. So divide by 5. Divide by 5. This cancels that. Therefore, we can see that n equals to 103. So the 103rd term is going to be equivalent to 570. All right. Perfect. And that's it with a linear pattern. Now we have to dive into a quadratic pattern. Okay. So let me just quickly erase everything so that we can have space. Okay. Awesome. So now we find we can do this. So question 2, they say the following information is given about the quadratic number pattern. So the pattern that we're working with is what? Quadratic. Right. We are given t1 equals to 3. Okay. So we have 3 as the first term. And then we are given t2 minus t1 to be 9. But we don't know the value of t2. But we know that t2 minus t1, we're going to get a 9. They also gave us t3 minus t2. Okay, we don't know the value of t3. But we know that when we minus t3 by t2, we're going to get 21. Alright? And because they told us that this is a quadratic number pattern, we can easily see the pattern here, basically. Remember, the second difference is always constant. So we're going to say 91 minus 9, which is 12, which means here you're always going to have 12. No? So, which means here you must have 33. So that when we say 33 minus 21, we get 12, right? Awesome. And then we can basically see that, okay, let's see, term 4 can be there. And then we're going to get up to term 5 because I see the first question says, show that term 5 equals to 111. Okay, sharp. So we have this and that, right? Oh, sorry. And that. We know that the second difference is constant. So which means 12 plus 33 must give us this one because this minus that gave us that. So which means, let's see, 33 plus 12 equals to 45. Okay, so here we get a 45. And I'm sure you can notice that from here to there you added a 12, from here to there you added 12, from here to there you added 12. Because the first difference of a quadratic pattern is a linear pattern. Eh? You need to know that. That is very, very important. Okay. Then the last one. Actually, no, it's fine. Yeah, it's fine. Sharp. We don't need the other things. So let's see. The first question wants us to determine term 5. Ne? I want you to observe the pattern. Remember, term 2 minus 3. The answer is 9. Which means, if I say 9 plus 3, I'm going to get term 2. So let's see what term 2 is. Term 2 will be 12. Right? But I need to show you something. If we can say 21 plus term 2, we get term 3. Right? And then if we say term 3 plus 33, we get term 4. Do you see it? So let's do that actually. What is 21 plus 12? 21 plus 12, that is 33. Right? Which means term 3 is 33. Then we're going to say 33 plus 33, which gives us 66, which means term 4 is 66. Then we're going to say 66, we're going to say 66 plus 45 must give us term 5. So term 5 is going to be, okay, plus 45. That is 1 1 1. You can see it 1 1 1, right? 1 1 1. So that is how you're going to show it, basically. Sure. But the other way you can do this is this. Remember, we added this, we added that to get that, we added this to get that, we added this to get that, we added this to get that. So basically, simple terms, you can say term 5 equals to 3. You just put everything that we added. Plus 9, plus 21, plus 33, plus 45. That will give you 1 1 1. Right. So term 5 is 1 1 1. Then they say, show that the general term of the quadratic pattern is that. Okay, sharp. Remember, ladies and gentlemen, we have a special formula that we use to do that, which is basically, you know that this second difference is always 2a. The term 2 minus term 1 is always 3a plus b. The term 1 is always a plus b plus c. Right? Now let's start solving. Let's see now. Oh, sorry. So we can see that, okay, 2a equals to 12. Then we divide both sides by 2. We can see that a equals to 6. Right? That's that. And then we can see that let's see, 3a plus b, and no, I don't need this, 3a plus b equals to 9. Therefore we can see that b equals to 9 minus 3a. This guy must go that side. Then we can see that b equals to 9 minus 3 times 6, which is going to be negative 9. Because let's just verify on a calculator, 9 minus 3 times 6, that's negative 9. Awesome. And then we know that a plus b plus c equals to 3. Okay. We know that a plus b plus c equals to 3. We know that c is going to be 3 minus a minus b. Why? Because this will go that side and that will go that side, and they are all going to be minuses. So it's 3 minus 6 minus negative 9. Let's see what is that. 3 minus 6 minus 9. That is 6. So the value of c equals to 6. Therefore, we have Tn equals to our a. How much was our a quickly? 6. So you're going to have 6n squared minus 9n. That was our b plus 6. Let's see if we proved it properly. Yay, we didn't. Then the 2.2.3, they say show that the pattern is increasing for all n elements of natural numbers. Alright, so to show that this is increasing, ladies and gentlemen, we're basically going to, let's see, we are going to find the turning point, which is the highest value. Remember, a quadratic pattern, it's a parabola. Sharp. So we are going to use the knowledge of calculus, the derivative of the pattern, which is 12n minus 9. So I'm deriving that equals to 6. I have n equals to 9 over 12. Why? Because this will go that side to be plus 9. You need to divide by 12 so that the n is isolated. And this becomes 3 over 4. Which means the smallest possible value that n can be, it's approximately equals to 1. Because 3 over 4 is it's 0.75, which is going to round off to 1. Right. Sharp. So if the smallest value is 1, the smallest position is 1, it means the smallest value will be on position 1, which is 3. Which means for this pattern, the smallest value that we can have is 3. Therefore, the pattern is going to be positive. It's going to be natural numbers. It's going to be increasing because the smallest is 3, and then from there we have to be going up. So you're going to say, okay, therefore term number 1 equals to 3 is minimum. How did I know that this is minimum, not maximum? If you check it, this is the parabola facing down because there's a plus there, so it's going to have a smallest value there. No, this one is going up. Sorry, it's going up. So this is the smallest value, so it keeps on going up basically forever and ever. Right, and then you're going to say, therefore Tn is always increasing. Okay, and that's it for this video, ladies and gentlemen. Thank you for watching. Aluta continue.